Good day, everyone. Today I'll be looking at the chain rule of differentiation. Now, one thing to note is that the chain rule is used when you have a situation with a function of a function, meaning you have a function operating on another function. So I can write an example here just so you can have a better idea of what I mean. Okay, so for instance you have a function, let's say x squared plus 1, right? X squared plus 1 in itself is a function. Let's call this f of x for now, right? And now we can have another function, let's say g of x, which is equal to x squared plus 1 all cubed. Now, when differentiating functions such as g of x, we have to use the chain rule. So this is what is meant by a function of a function. Here we have the x squared plus 1 in the brackets. Now that within itself is a function, but then the x squared plus 1 is being raised to the third power. Now raising it to the third power is another function. So basically we plug f of x here and raise it to the third power. Hence a function of a function. Let's say for instance we had a trig function like sine, and we use x squared plus 1. Sine of x squared plus 1. Then this again is another function of a function, because x squared plus 1 is a function and it is being operated by the sine function, manipulated by the sine function. Okay, now we can do an example here of the chain rule, and let me write the formula for using chain rule for finding dy dx. Now it states that if we have a function y equal f of u, right? Now, and let me write where u is a function of x. Now I use x in this case, but basically it could be any variable. Remember that this is just to generalize a formula, but let's say the dependent variable here wasn't y. What if it were h or p, or so it could be anything, right? And u here is just a function. In this case I use x. U could be a function in h, t, like t for when you're dealing with time, something of the sort. Okay, so just stating that. Now it says that the derivative dy dx would be equal to f prime of u, meaning you differentiate f with respect to u, f prime of u, multiplied by du dx, right? And you could also write it like this: dy du times du dx. Now so dy dx is equal to that. Now the chain rule can be stated either like this or like that. For our case where I use u here and x here, but as I said, u is just some function. So it doesn't have to be a function in x, it could be a function in t or something else. Right, now let's apply this formula here to a problem. Let me write something here. Let's say we have y equal x cubed plus 1 raised to the 5th power. Now we can say let u equal x cubed plus 1. Therefore we would have y is equal to u to the 5th power. Since we let u equal x cubed plus 1, we just replace x cubed plus 1 with u, right? Now the formula states that dy dx, or dy by dx, is equal to dy du times du dx. So let's find dy by du. Now let's just draw a line there and write dy du. And of course, we're just going to differentiate it like it's a normal function. So dy by du is just simply 5u to the 4th power. Remember, you multiply by the power, keep the u and reduce the power by 1, so it's 5u to the 4th. And our du dx would just simply be 3x squared. Good. Now all we need to do is just plug in these results in the formula. Therefore dy dx would be equal to dy by du, which is 5u to the 4th, multiplied by, could use a bracket, multiplied by du dx, or du dx is 3x squared. Now we can tidy that up. So 3 times 5, that's 15, and that's x squared u to the 4th power. But now remember that we made u equal to x cubed plus 1. So here we're going to back substitute, meaning putting back what we substituted u for, or what we substituted for u. Sorry. And that was x cubed plus 1. And this is our u, and u is being raised to the 4th power. So there we have it. Dy dx is equal to 15x squared times x cubed plus 1 all raised to the 4th power. And we can move on to another problem. Now I'm going to do a trig problem. No, I haven't done trig differentiation on the channel as yet, but still, let me do a trig problem. There might be persons who already know how to do this and want a trig problem. So let's do a trig problem. So let's say we have sine y equal sine of 3x. Now if we followed from the previous question, we will let u equal to 3x. Now would have y equal to sine of u, because we let u equal 3x, so therefore we can substitute 3x for u. Now let's find our dy du and our du dx. Let's find du dx first. That is just 3. Du dx is equal to 3, and our dy du is equal to cosine u. Just in case you didn't know before, when you differentiate sine, you get cosine. So if you differentiate sine of x, then you get cosine x. If you differentiate sine of y, that's cosine y. If you differentiate sine of u, that's cosine u. So that's just dy by du equal to cos u. Now let's find dy dx. Now dy dx is equal to dy du, which is cos u times du dx, which is 3. You can put the 3 out here, so that's 3 times cos u. And now if you remember, we back substitute, so that's 3 cos u, but u was 3x, therefore 3x remains in the brackets. Now there is a shortened way to look at this. Basically, you can say that, okay, dy by dx of sine 3x, you just differentiate sine normally. So if you differentiate sine, you get cos. If you differentiate sine 3x, you're supposed to get cos 3x, right? Now what we have to do next is to multiply by the derivative of what's in the brackets. Now the derivative of 3x is just 3, so we multiply it by 3. So basically you can say that you differentiate the function normally, assuming that 3x is just a single variable without a coefficient. That's what I mean. As in sin x, look at the 3x as if it were sin x and just differentiate it. So if you differentiate sin x, you get cos x. If you differentiate sin 3x, you just write cos 3x. Then you multiply by the derivative of what is in the brackets, and what is in the brackets is 3x. So if you differentiate 3x, you get 3, so you multiply by the 3. You could just write down another example here. What if you had sine of x squared plus 2x? Good. Now as I said, let's use h equal. Now dh dx, that would just be equal to, now as if you can recall, let me just get rid of this here. If you can recall, you differentiate the sine normally, which if you differentiate sine, you get cos. So that's cos of whatever is in the bracket. Good. Then you multiply by the derivative of what is in the bracket. Multiply by the bracket term derivative, if you want to say it like that. Now derivative of what's in the bracket, that's 2x plus 2. So that would be the result, 2x plus 2 multiplied by the cosine of x squared plus 2x. Now that is basically the chain rule in a nutshell. let's just look at another problem here quickly. Okay. Alright, good. Let's just look at an exponent problem with exponents. Again, I haven't done differentiation of exponents on the channel, but you can learn now. Okay. Let's say we have y equal e to the x. Let's just start simple. This does not require a chain rule, by the way. I'm just doing this so that you can have a basic understanding. Now dy dx, that would be equal to e to the x. So if you differentiate e to the x, the result is just e to the x. Now let's get into a problem. Let's say we have h is equal to e to the 2x power. Sorry, that better. E to the 2x power. Now, if you remember from before, basically let u equal to 2x, then you say h is equal to e to the u. Now you find your du dx and your dh du, in this case dh du dx. Now du dx is simply 2. If you differentiate 2x, that's 2. And if you recall from up here, if you differentiate e to the u, the result should be e to the u. Now the chain rule states that dh dx should be equal to dh du. Now we have dy du in the formula, but in this particular problem the function is h, so dh du, which is e to the u, and we multiply that by du dx. Now du dx is just 2, so let's put the 2 there, so that's 2e to the u, and of course we substitute our u for what we had originally, which was 2x, so the result is 2e to the 2x. Now instead of having 2x here, it could be x squared, it could be anything. It could be a sine function, cos, tangent, natural log, it could be anything, right? So let's just clear this and try another problem. Now with this other problem, you can pause the video and try it on your own so that you can see if you're correct, because it makes no sense not to practice. You have to practice, so you can pause the video and try it on your own. So let's say we have y equal e to the x squared plus 3x plus 2. Therefore, let's find dy dx. Now, using the chain rule, you let u equal to this function, which is x squared plus 3x plus 2. Therefore we have y is equal to e to the u. Great. Now let's say we find our du dx and our dh wow, this should be a y. Good. And we find our dy du. Now du dx is simply equal to 2x plus 3. Good. And dy du, that's equal to e to the u. Okay, so now let us write the answer. So dy dx, that's equal to dy du, or dy du is e to the u, e to the u, and we multiply that by du dx, and our du dx is 2x plus 3. Now we can just put the 2x plus 3 at the front. E. Now remember that u is x squared plus 3x plus 2. So that's x squared plus 3x plus 2. Great, and that is our answer. I'm going to end the video here. See you guys in the next video, and I'll probably make a video on differentiating trig functions, logarithmic and exponents in a later video. But from this video you should have a basic understanding of the exponents and the trig. So see you guys in the next video.